Okay, hello everyone. I trust you're doing good. In this video, I want to um, teach us number-based system. What a number-based system is. We have a lot to learn here. Okay, now first of all, I like to say that a number-based system is a method of representing numbers. Okay, it's just a method of representing numbers. Using symbols. We use symbols, but amazingly these symbols are also numbers. These symbols are called digits. Okay, so and each base has its digits. Yeah, for example, base 2 has only two digits, which is 0 and 1. 0 and 1. Now that is important. So if I'm writing a number in base 2, it means that I will always only have 0 and 1 digit. For example, I can have 1011 to base 2 like this. Okay, but I can never have 125 to base 2. This will be wrong because the digit 2 and the digit 5 does not exist in base 2. Okay, the same thing if I say base 3. Base 3, the only digit I have in base 3 is 0, 1, 2. Okay, you have, that's lower. Now the same thing if I have base 7, the only digit I have in base 7 is 0, 1, 2, 3, 4, 5, 6. Okay, so that means I can actually say something like 5, 4, 6 to base 7. Yeah, this is correct because base 7 can only have digits that is less than 7. It can never have a digit that is equal to its own value, right? Okay, so that's the first thing for you to note. Then the second thing for you to note is that the value of a digit, the value of a number base, number base depends on number one, depends on the digit itself, the digit in the number base. Then secondly, it depends on the position of the digit. Okay, so it depends on the digit and depends on the position of the digit. And the beautiful thing is that we can convert a number base from one base to another. Okay, so this is what I want you to note. But before I continue, I like to say that our normal counting system that we use every day, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, that counting system is actually called base 10. That's our normal counting system. That's the reason why base 10 has units 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. It stops at 9. Can you see that? Now that's very important. Okay, and that is why I mentioned that the value of a number base depends on the digit and the position of the digit. I'm going to explain that. Now look at this. If I look at this number, you can call out this number. Can you tell me what this number is? Yeah, I'm sure you are right. It is 2435. So we say 2000, right? Then 400 and 35. Okay, now 2000 simply means 2 times 1000. You see, 400 plus means 4 times 100. 30, there's plus. 30 means 3 tens. It means 3 times 10. That's what 30 is. Then 5 is just 5. Okay, now but there's something I want you to note is that, okay, I can just say 5 times 1. Now there's something because this is ones, there's something I want you to note, that this 1000 can be written as 10 raised to the power of 3. 100 can be written as 10 raised to the power of 2. 10 can be written as 10 raised to 10 is 10 raised to the power 1. Then 1 here can be written as 10 raised to the power 0. Can you see? So all of this is in base 10. It means base 10, base 10, base 10, base 10. Can you see? And so the lowest position is 0. Then you go 1, 2, 3, and it keeps going as you increase. So this is how you present base 10. But if I want to represent a number in base 5, let's say I have 324 and it is in base 6. I want to represent it in base 6. What this means is that according to this, I won't say 324. It's actually wrong. When you say 324, you are talking about base 10. You are dealing with base 10. So instead, there is no way to say this. I would rather say 3, okay, multiply each one by 6, plus 2 times 6, plus 4 times 6. Then you come here, you have 0, 1, and 2. This is how you represent it. So that means 3, 2, 4 to base 6 is actually represented this way. Okay? And no other way apart from this. Does it make sense? Okay? So now that now leads us to how to convert from other base to base 10. Okay, now how do we convert from other base to base 10? Let me convert the following to base 10. Let me say 10112. Then B, let me say 2224. Then this, let me say 34. Then D. Okay, I think this is enough. Okay, these are different bases. This is base 2, this is base 4, and this is base 5. I want to convert it to base 10. And this is one of the easiest things we can talk about. Now, the way to convert to base 10 is by writing out the number, spreading it out the way it's supposed to be written. For example, if I say 1011 to base 2, now I'm going to multiply each of these digits with the base, right? Before I now put the power, the position. So, like here, I'm going to say 1 times 2, plus the next one is 0 times 2, plus the next one is 1 times 2, then plus the next one is another one, this one again times 2. Can you see? So this 1 times 2, 0 times 2, 1 times 2, then 1 times 2. Then from the last 2, since it's base 2, I write their position 0, 1, 2, and 3. Okay, so having this now, this I can now go ahead and solve this, because this means 1 times 2 raised to the power of 3 is 8. That means 2 times 2 times 2 is 8. Then plus this is 0 times 2 raised to the power 2 is 4, which is, okay, yeah, 2 raised to the power 2 means 2 times 2, which is 4. Now this is now 1 times 2 raised to the power 1 is 2, plus 1 times 2 raised to the power 0 is 1. Any number raised to the power 0 is 1. So 1 times 8 is 8, plus 0 times 4 is 0, plus 1 times 2 is 2, plus 1 times 1 is 1. So are you seeing that? So 8 plus 0 is 8, plus 2 10, plus 1 11. So this is 11 to base 10. So what this thing means is that 1011 to base 2 is the same thing as 11 in base 10. As simple as that. Okay, now let's try the second one. Now for the second one, we have 2 2 2 base 4. Now to convert it to base 10, like I said, I will write everything in base 4. That means 2 times 4, 2 times 4, 2 times 4. So this will be 2 times 4 plus 2 times 4 plus 2 times 4. Now I will write the position. This is 0, 1, 2. Can you see that? So I start from here. So this is going to be 2 times 4 raised to the power 2, means 4 times 4 is 16. Plus 2 times 4 raised to the power 1 is just 4. Then plus 2 times 4 raised to the power 0 is 1. Any number raised to the power 0 is 1. Okay? So this will now be equal to 32, plus 2 times 4 is 8, plus 2 times 1 is 2. Can you see that? So that will now be equal to 32 plus 8 is 40. 40 plus 2 is 42. So that means 222 to base 4 is the same thing as 42 to base 10. I hope this makes sense. Okay, so that is beautiful. That is beautiful, right? So the next thing is 34. 34, sorry, not 34, is base 5, so I can't say 34. 34 means I'm calling it according to base 10. So for this now, 3, 4, 5, base 5 means 3 times 5. 3 times 5 plus, this is 4 times 5. Okay? So, and we just have 3 times 5, 4 times 5. Then the position, this is 0, and this is 1. So this is also saying 3 times 5. Plus this is saying 4 times 1. 5 raised to power 0 is 1. So 3 times 5 is 15. 4 times 1 is 4. So 15 plus 4 is 19. So what this means is that 35 or 34 to base 5 is equal to 19 to base 10. Okay, so this makes sense, right? Okay, so see you in the next video.